Hey, yo, friends. Get him in here. A little under the weather, so really apologize. But I hope you can still hear me and understand what it is that I am sharing with you. Today, we're going to do 3 examples together, and then you're actually going to try 3 problems on your own. So, for this first example of 5-1 day 3 notes on writing expressions from word problems, example 1, Josiah wants to buy a DVD player. Good for Josiah. He already saved $25, probably some important info. And he plans to save an additional $10 each week. We're going to define a variable and set up an expression to find how much money Josiah has for any number of weeks. So for 2 weeks or 7 weeks or 12 weeks, I want to set up an expression so that I can plug in any number of weeks in order to figure out my final amount of money that Josiah has. So therefore, to define our variable, we're just going to use x for now. You can actually use any variable you want, but just make sure that you define it fully. So x, what do I not know? Well, what I don't know is set up an expression to find how much money Josiah has for any number of weeks. That's what I don't know. So if I were to say number of weeks, make sure to be very specific. Don't just say weeks. So that's what I'm trying to identify for any number of weeks for our X. I know that it's $25 and $10 each week. So this number or this word each represents multiplication. So go ahead and write to multiply. So $10 each week. And I know that week is our variable. So therefore, $10 times the number of weeks, aka 10x or 10 times x. And then we already have saved $25. So that's going to be a plus 25. You could also write this as 25 plus 10x, but make sure that x is attached to the 10 because it's $10 each week. So for 3 weeks or for 4 weeks, I know that I'm taking $10 times that number of weeks. So here's our expression. Then we're going to simplify to find how much money Josiah will have saved after 11 weeks. So what I'm saying there is that I'm going to replace the x with the number 11. So in our expression, 10x plus 25 instead of x, I'm going to replace it. So I've got 10 times 11 weeks plus 25 and then order of ops. I'm just going to work it from left to the right because it is multiplication, then addition. So 10 times 11 is 110 plus $25. Final answer here is $135. And obviously, because these are word problems, normally we do need a sentence, but because these are just notes, we're just going to go ahead and move on. Okay, example 2. A website charges 99 cents to download a game and $12.49 membership fee. Define a variable and set up an expression for any number of games downloaded. So some important info, this much to download a game. So if I'm getting 1 game, it's 99 cents. But if I'm getting 3 games, what I'm taking with the 99 cents is I'm actually multiplying it, or just, again, repeated addition. So 99 plus 99 plus 99. But to quicken us up, like let's say that we buy 12 games, we're going to take the 99 cents times our number of games, so the number 12, and a membership fee. This membership fee we're actually just paying 1 time. So again, we are needing to define a variable. So again, I'm going to use x. So x, what I don't know, set up an expression for any number of games downloaded. That's what I don't know. So x is the number of downloaded games, or just number of games is fine. And then with that, I know, like I mentioned earlier, you're taking the number of games times that 99 cents. Because if we get 12 games, we're going to take 99 cents times 12. So 0.99. You could also put a 0 there if you'd like. X. And then plus the $12.49 membership fee that you just pay 1 time. So now we are going to replace the X with, it looks like it says, then simplify the expression to find how much it would cost to download 6 games. Therefore, I'm replacing the X with 6. So 99 cents times the 6 games that we're downloading plus the $12.49. So 99 cents is close to $1, obviously. So 6 times $1 is just $6. but then I'm taking away 1 cent. So again, I'm trying to do this all in my head since there are still no calculators. 1 cent per dollar, so minus the 6 cents. $6 minus 6 cents is $5.94 plus $12.49. Just a quick reminder to add these two things, $5.94 and $12.49. You do need to line up our decimals. So we got 13, 14, 5, 6, 7, 8. Therefore, our final answer is $18.43 if I get 12 or 6 games. And moving right along. Example number 3. Tony has 4 less than twice the number of t-shirts Jacob has. We're going to define a variable and set up an expression to find the number of t-shirts Tony has based on the number of t-shirts that Jacob has. Well, in order to find Tony's shirts, first we need to know how many shirts Jacob has. So that actually is going to be our variable. So the number of shirts Jacob has. So with Jacob's number of shirts, I know that Tony has 4 less than. So 4 less than, that's like the minus 4. And then twice the number of Jacob. So if I'm taking twice the number of Jacob, that means I'm multiplying it by 2. So 2x. And then I'm taking 4 less than that in order to find Tony. So then also, if you're unsure if X is the number of shirts Jacob or Tony has, you can also look down below because it says then simplify the expression if Jacob has 12 shirts. So because 12 is the number that I'm plugging in, notice that the Jacob is the person, obviously, that we do not know. So in our expression, instead of 2x, we're replacing x with the number 12. So notice that here you can put it with like the multiplication symbol like that, the dot, or you can use the parentheses like I did up on example 2. But then you're going to subtract the 4 t-shirts. So 2 times 12 is 24, and then I subtract the 4. So I know if Jacob has 12 shirts, that Tony has 20 shirts. All right, and then if you are listening to me right now, you're listening clue, I want you to draw a big fat smiley face by the number 20. Just a smiley face to make sure that you are, in fact, listening to notes. A smiley face by the number 20. Okay, go ahead and turn over notes. Alrighty, so we're going to do these YouTube problems a little bit differently in the Edpuzzle notes. We're actually going to set up the expression. You're going to try it and then select the multiple choice answer that is correct. Then down below, you're also going to get an answer when you simplify it out, when you obviously evaluate it. So make sure that you are trying to understand these and you're not just clicking on the multiple choice option to move on with notes quicker. All right, this first problem. SAC students are going on field trip to the Johnson County Christmas Bureau. Field trip will cost $9 per student, and the bus to get there costs $75. So it's a one-time fee of $75. You want to define a variable and set up an expression to find for any number of students. Go ahead and set up this expression, and then select the correct multiple choice option, and then move on to the second part. Go ahead and pause. Alrighty, here is my expression 9x plus 75. You could also write this as 75 plus 9x because of the commutative property. And then notice I've also set up or defined a variable. So x is the number of students on the bus. All right, go ahead and pause to figure out how much it would cost for 13 students. And here's my answer. Notice that I have shown all the work. Again, I'm just trying to prove to you that I'm not also using a calculator. Final answer right here is 192. Okay, the next you try problem, same thing. Jeremy has 7 more than 1/5 the number of baseball cards that Michael has. Define a variable and set up an expression to find the number of baseball cards Jeremy has based on the number of cards Michael has. Again, if you're unsure if it's Jeremy or Michael, look down below. It says, then simplify the expression to find the number of cards Jeremy has if Michael has 35. So because I'm saying that Michael has 35, that in fact is going to be your variable definition. So go ahead and write that with me. Number of cards Michael has. because that's what we're plugging in down below. And then with that, I want you to pause, select the correct multiple choice expression for this problem. And take a look, 7 more than. Notice that I put the 7 at the end. Obviously, addition is commutative, but if I'm having 7 more than something, I'm adding 7 to it. And then 1/5 the number Michael has. So 1/5 x plus 7. Okay, then I want you to go ahead and evaluate or substitute in the number 35 for x, and then check your answer with me. And since we know how to multiply a fraction with a whole number, we put that over 1, cross simplify. I know that 1/5 times 35 is 7, so then 7 plus 7 is 14. So what that means, if we were writing a sentence, is that Jeremy has 14 baseball cards. And this last one, Grace collected pledges for her charity walkathon. She will receive total contributions of $65.50 in addition to $21.75 for every mile that she walks. Define a variable and set up an expression to find for any number of miles walked. Go ahead and pause this video. I want you to define a variable and set up this expression, then check it. Go ahead and pause. And here's our expression, 6550 plus 2175x. Again, you can also switch those around because the commutative property. I'm going to make sure that x is, in fact, attached to the 2175 for every mile. That's kind of like for each mile. And we talked about how each represents multiplication. All right, go ahead and substitute in the number 6. Do not, I repeat, do not use a calculator. Okay, we're not dealing with that yet. All right, go ahead and pause. And finally, our answer here is going to be 196. Notice again that without a calculator, I showed all my work, 2175 times 6, and then I added that to 6550. Final answer is $196 if Grace walks 6 miles. Alrighty, that's the end of lesson 5.1. Hopefully all that translating practice will make our problems and our quiz and our test on the road just that much easier. Okay, thanks, guys.